Okay, let's have a look at what we need to do if we are being asked to sketch a cubic function. All right. How do we recognize it's cubic? Because obviously it's going to have the highest exponent in the equation is going to be to the power of 3, and obviously that's how you're going to tell that it's cubic. Okay. The best way to approach sketching a cubic graph is to just take it kind of step by step. Okay, and that's how I've put it in this lesson. And if you can break it down into steps, it's actually a nice way to approach the sketching of these graphs. Okay, so you've been given a cubic equation and you've been asked to sketch it, and these are the steps you're going to follow. Step 1, you want to determine what the shape of your graph is going to look like. You don't need to know anything specific just yet, you just want to know what kind of shape it's going to look like. How are we going to tell? Okay, we are going to look at the a value. All right, that's the value that's in front of your x cubed. And we are going to determine whether it is positive or whether it is negative. If your a value is greater than 0, obviously anything greater than 0 is positive. That means that your shape is going to have a positive shape. So it's going to be basically the way you're going to identify it is that it starts by increasing and then it finishes off by increasing as well, okay? And then obviously between the two turning points is where the function is decreasing. So basically, as we've seen over here, your increasing end behavior is what you're looking for in terms of a positive cubic graph. If your a value is less than 0, so if you've got an a value that is a negative, it means your graph is going to be a negative shape. What does that look like? It's going to start by decreasing. Between the two turning points, it will increase, but its end behavior, the way it finishes off, is it finishes off by decreasing, and that's how you're going to know that it's a negative cubic function. Right, once you've determined the shape of the graph, we're then going to have a look at the step 2. And step 2 is always going to be find your y-intercept, okay? Now, how do we do that? Just like any function, how do I find the y-intercept? I let x equal 0, okay? If I let x equal 0, let's go back to the original equation. If I let x equal 0, that's going to cancel out and be 0. That's going to be 0, that's going to be 0, and what am I going to be left with? Well, d, all right? So you can automatically assume that the constant term at the end is actually your y-intercept. It's a nice quick shortcut for you to remember. So step 2 is to identify the y-intercept. We do it by saying let x equal 0. Step 3 is then we want the x-intercept, okay, and that gets done by saying let y equal 0. Now this requires a bit more work, okay, let's go back to the original equation. If I were to let y equal 0, if I were to take that y over there and let it equal 0, typically what's going to end up happening is that you're going to have some kind of cubic equation that you're going to have to factorize, okay? Now, it's not impossible, it's not ridiculously hard, it's just requiring a little bit more work, generally along the lines of your remainder and factor theorem, okay, and using sort of your more advanced forms of factorizing that you would have learned in previous sections of algebra, okay? So yeah, that step over there is the one that's quite heavy in terms of working out, so just know that and be prepared for it. Then step 4. Okay, so what have we got so far? We know the shape of our graph, we know the y-intercept, we know the x-intercept, okay? Then we want the stationary point. Now, the stationary point, okay, is basically what we call the turning point of your cubic function. If I have got a cubic graph, which I'm going to draw a very rough one of over here, okay? If I've got a cubic graph and I draw a tangent to the curve at the two turning points, essentially what I know there is that the gradient of your tangents at those 2 points are absolutely flat. And if the gradients of your tangents are flat, it means that the derivatives, or the derivative, is equal to 0. Okay, so to find the x-intercepts of your stationary points, you have to work with the derivative of your function and you have to let it equal 0. Okay, that's going to give you the x coordinates of your stationary points. You then substitute the x values back into your original equation, and that will give you the y coordinate that belongs to each of the x coordinates, and you get your turning points. Okay, so stationary points, derivative equals 0. That is the key to finding the stationary, or what we also could call the turning points. And lastly, we then have this point called the point of inflection. Okay, now your point of inflection, again, if I just draw myself a quick cubic graph, okay, your point of inflection is the point where your graph goes from being what we refer to as being concave down, all right, to becoming concave up, all right. So it's that change in the shape of the function from it being a negatively shaped graph to then turning and suddenly becoming positively shaped. And the way we calculate the point of inflection is we work out our second derivative, all right, so basically it's the derivative of the derivative, and that's also going to be made equal to 0, okay? Again, that gives you the x value of the point of inflection. You then take that x value and you sub it back into the original equation, and out will come the y coordinate, and there's your point of inflection, okay? So in terms of sketching a cubic graph, those are the 5 steps that you want to follow. Shape, y-intercept, x-intercept, stationary points, point of inflection. Okay, if you've got those, you should have what you need to actually draw the cubic graph. All right, so we'll put that theory into practice in the next video, and I'm sure that you'll understand it well. Well done.